When Charles Goodyear invented the pneumatic tyre, he could not have anticipated the major environmental challenges they posed. More than 1 billion waste tyres are generated annually throughout the world. And this is only half of the negative side of the equation. Tyres are constructed to be virtually indestructible, and while this is advantageous for the automotive industry, it creates many challenges when the tyre reaches the end of its life cycle. The long-term profitability of the Molectra system is ultimately assured by the identification and design of a range of value-added products which can be created directly by the process or manufactured using products created by the system. Each tyre contains valuable energy and resources of high-carbon compounds, metal and fibre trapped by the manufacturing process. The name Molectra was designed by combining the words molecular transformation. Waste is transformed at a molecular level into useful, innovative products for solutions to environmental problems. The Molectra process begins with the removal of the bead wiring in tyres. The tyres are then sliced into manageable pieces. This two-step process is a surprisingly simple solution to a problem that tyre recyclers have been struggling with for years. The bead wire is the toughest component of a tyre, and it requires enormous amounts of energy to shred into small pieces. With the Molectra system, each bead wire is removed in one piece before the tyre is sliced into pieces. With the Molectra debeater slicer, the tyre is conveyed into the platform where it is automatically positioned. A hook is raised through the tyre and pierces the tyre, drawing out both of the bead wires. Secondly, a slicer is lowered, which slices the tyre into manageable pieces. The segments are then soaked in sol oil, a softening compound extracted from tyres which conditions the rubber as the tyre pieces travel through the Molectra duct system. In a full-scale operation, this duct system is anywhere from 500 to 1,000 metres long. The pipe itself measures 1.4 metres in diameter. As the tyre pieces are fed into the pipe, they are mixed with the sol oil solution and conveyed along as each pipe segment rotates. The treated rubber tyre pieces are then subjected to pressure forces, which separates the three components of the tyre and recovers all of the rubber. Inside the Molectra separator, the softened tyre pieces are squeezed and twisted between the four sets of rollers. With this action, the steel and fibre cords remain in long pieces since the rollers don't actually cut them. The rubber is torn away, and by the end of the run, it is free from the steel and fibre. Magnetic separators remove the metal component of the tyre pieces. Then screening and air flotation units recover fibre. The rubber is ground to varying crumb sizes. The fine crumbs are treated by low-temperature microwave to recover the sol oil. This neutralizes the rubber and makes it virtually pure, with a Shore hardness of 60. The first stage of the Molectra process neutralizes the softened rubber by driving off and recovering the sol oil from both coarse and grated rubber crumbs. The sol oil is then filtered and blended for reuse. Depending on client requirements, grated crumbs are then removed for sale or incorporation into value-added products. This fine rubber crumb is then packaged for the rubber market. A key component of the Molectra system is the Molectra process, which utilizes a continuous feed microwave carbonisation unit to break the rubber down into carbon, hydrocarbon, zinc oxides and gas. The coarser rubber fragments continue through the Molectrovac process unit, where they are gradually heated under vacuum to between 380 and 1300 degrees Celsius. As the temperature rises, the bonds between the carbon, sulfur and zinc molecules are broken, yielding the gaseous hydrocarbons and oxides used in the original tyre manufacturing process. These are recovered within the unit and distilled to achieve valuable hydrocarbons in light, medium and heavy fractions, along with zinc and sulfur oxides. The residue of the process is 97.3% pure carbon, which can be further treated to produce carbon black and activated carbon. The use of microwave energy in the patented Molectrovac process is integral to the success of the system, allowing energy-efficient precise heating of the entire mass at the various stages of the unit. The process achieves a remarkably high yield of oil and carbon. Each passenger tyre yields 3.9 litres of oil and 3.8 kilograms of high-grade carbon, which is 97.3% pure. All of the waste tyre ends up as useful products. The steel from the bead wire and belting can be sold as scrap metal or made into buckshot for sandblasting. The fibre used in tyre belts can be used in the production of plastics or used as concrete reinforcement. Generally, the recycling of spent tyres on a large scale has not been profitable. The Molectra system changes this, with low operating costs and high profit margins enabling viable recycling of a seemingly endless resource. The process directly produces saleable products with an estimated value of $11.41 per car tyre. With further value adding, this can be increased. Currently, most tyre outlets pay to have spent tyres removed. The environmental benefits of this process cannot be underestimated. Various levels of governments are likely to offer incentives to facilitate the establishment of commercial Molectra processing plants within their constituencies, and rightly so. Here at Molectra, we're proud of what we have achieved and look forward to sharing our vision with a limited number of like-minded innovators who strive for the elusive mix of profitability with social responsibility from their investments.